Hello students, welcome to Studi.live. In this lecture, we will be starting with very interesting MCQs, that is MCQ from solid state chapter. Yes student, these MCQs are really very important but yet easy if you revise or you are thorough with all the concepts. Yes, so we have our first MCQ in front of us which says that which type of defect has presence of cations in interstitial site? Yes student, you must be knowing that the defect is very much important topic as well as theory as well as for MCQ also. Yes, so we have our first question based on defects only, in which they are asking us defect has a presence of cation in interstitial site. See, the first important part is in interstitial site and they are talking about ion, that is cation, okay, and we know this part very well. It is Frenkel defect because in Frenkel defect cation size is small, it is missing from its original site and coming to interstitial site. Yes or no student? One more important thing, learn the examples of Frenkel defect as well as other defects like Schottky defect and others. Yes student, let's go to our next question. So students, we have our next question in front of us. Let's try to understand what it is saying. So it says that which one of the following compounds show both Schottky and Frenkel defect? Student, this example is very important because we know different ionic compounds, like they show either Schottky defect or either Frenkel defect, but one ionic compound is there, it shows both the defect. Okay, I am giving you answer for this, but I also want you to learn, okay, why it is showing both Frenkel as well as Schottky defect. For that, but obvious, the answer for this question is AGBR, but obvious, but let's try to understand why. Okay, see, if I am talking about Schottky defect, we know that in Schottky defect cation and anion both are missing from its original site. While we talk about Frenkel defect, we can say that cation or any ion is missing from its original site and it is present in the interstitial site. Yes or no? Now, basic difference between both, Schottky defect, the ratio for the radius ratio, that radius for cation and anion are almost the same, while for Frenkel we can say that cation is smaller in size than anion. Yes or no? So student, if we talk about AGBR, why it is showing both Schottky as well as Frenkel defect, let's talk about it. Because, very simple reason student, is because of its radius ratio, because of this radius which is intermediate. Intermediate between what? Intermediate between the radius that we want for Schottky as well as Frenkel. Schottky size should be almost the same, radius should be almost the same. Frenkel, cation small, anion big, but in case of AGBR, it is size, that is radius fits, it is intermediate to the both the criteria for Schottky and Frenkel. So AGBR is the example you need to remember that shows both the type of defect. I am hoping you are going to remember this example and why also. Yes student, so let's go to our next question. A compound is formed by element X, that is considered as a cation over here, and Y, that is considered as anion. Ions of Y forms a cubic close packing, that is CCP structure, and ions of X occupy the octahedral void. Yes, what is the formula for the compound? Okay, this is a simple question they have asked. What is the formula of the compound? Right? So how we'll discuss that, how we'll solve that students? Let's try to understand this part very well. We know that in case of CCP structure, that number of octahedral voids, the relationship between octahedral voids and tetrahedral voids are what? So we can say that always tetrahedral voids. I am hoping you know very well about octahedral and tetrahedral voids. Yes? If you don't know, I will suggest you to revise, to go through our video lectures that is based on solid state. We have specially made it for you. So always in CCP structure, tetrahedral voids are twice the number of octahedral voids. Very well, but obvious. Over here they have said X occupies octahedral void. So for octahedral, if I have X, then can I say Y is occupying cubic close packing, okay, that is tetrahedral void. So can I say it's 2 times Y that I will be needed, but obvious relationship between 2. So formula that I am going to get would be XY2, which is option number A. Am I clear with this? Yes. So this type of question you need to solve within a 10 seconds if it has been asked in your exam. I am hoping you understood this part very well, how you need to solve this. A compound is formed by cation C. So cation we have, which is C, and anion that we have, which is A. The anions forms HCP, hexagonal closed pack lattice, while cations occupies 75% of the octahedral voids, okay, and they are asking us the formula of the compound, okay. This is going to be really interesting question. So how we'll be dealing it with, okay. So for that, first and important thing, let's try to understand in hexagonal closed pack structure, because they have asked us about the hexagonal closed pack structure only, the number of anions, because see, cations occupy 75% of the octahedral voids, means anions ka 75% they are asking us. So can I say that for the HCP structure, let's find out the anion. How many anions are there in a HCP structure, that is for the A I am talking about. So we can say that the anions are, total number are 6. I am hoping you know this part, we have discussed in my normal video. Yes. Now they are telling us that cations occupy 75% of it, yes or no. So for the cation, that is C, they are occupying 75% of this. So 6 ka 75%, so 75, that is upon 100, the answer will be getting is approximately, it is equals to what, students? Approximately we will be getting is at as 9/2. Am I correct with it? So simply we can say that from this 2 value, the answer that we are having right now is, see, in option we have cation first, I am writing cation ka C first, it is 9/2, and anion that we have is 6. Yes student, but obvious the numbers are there, it is not in ratio, so we are going to multiply on both the side by 2. So we will be having C 9, A 12, again we need to take a ratio, this both comes in 3 ka table. So we have C 3, A 4, as I have divided by 3, just check where it is, okay, C 3, A 4. The thing that you need to understand here, the important part, and that is the 75% of the octahedral voids, means anions are there we have, so 75% of that you need to take. Again the ratio, if it is there, it can't be in the ratio, so we have multiplied that by 2, and you need to have simple whole number ratio. So for that we have divided it by 3 to get our final answer. I am hoping you understood this part very well. So in the next question student, we have the contribution of particle at the edge center to a particular unit cell is what? Half, 1/4, 1 or 1/8. Let's try to understand the logic behind it, then directly go for the answer. Yes. So we have edge center. So first we need to understand what do we mean by edge center. For that, let me give you one simple representative diagram so you will understand in a better way. So let me draw one cube for you over here. Okay. So in this cube students, we are trying to know how many edges are present or what is edge center is actually mean by over here. Okay. So see over here in this case we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are the edges which is present. Okay. If you notice this very carefully, whatever atom that is present on the edge center, whatever edges we have on that edge center, that particle that we have present, the particle is actually surrounded by total 4 unit cell, okay, total 4 unit cells. So, the contribution it is doing for the per unit cell would be what? Suppose that we have ion that is present, atom, the particle, precisely let us use the word particle which is present at over here, okay. It is been shared by 4 unit cells, 2 below, 2 above. So, if I am talking on 1 unit cell, particular unit cell, so its contribution would be how much? So, again we can say out of 4, if it is we are talking about 1, so it is 1 by 4, yes or no? So, answer for this question would be 1 by 4, but I will request you all, rather than just learning about edge center, I want you to revise for all of the things. Means what? For example, if I am talking about, corner student, so whatever particle that we have at corner, it has been surrounded by 8 unit cell. Okay, so if I am talking about its contribution per unit cell would be how much? So, out of 8, we are talking about only 1, so it is 1 upon 8. Am I clear with this? As I discussed with you, for the edge center, it is 1 by 4. For the face center student, we have 6 face in the cube. So, every particle that is present on the face center, it has been shared by 2 unit cells. So, contribution per unit cell would be how much? You are absolutely right, it would be 1 by 2. And last but very important, if the particle is present in the center of the unit cell, but always it has not been shared with any other unit cell, it is present inside the unit cell, so its contribution would be 1. Okay. In this MCQ, we have discussed about the edge center, but obvious it is 1 by 4, but I have also given you the basic idea for all the different things like corner, edge, face and center. I am hoping you understood this part very well. Okay. That says that how many total spheres of a constituent particles are present in a BCC type of unit cell, and we have our option in front of us. To understand this topic, let us first try to understand BCC type. You must be knowing BCC structure, that is body centered cubic unit cell, yes or no? So, what was that? See, I want you in exam to answer directly, but understanding is more important, so it would be better for you in exam to write the answer in a quicker manner. So, in BCC type of structure, we have particles on every corner, we have 8 corners, so 8 particles, 1, 2, 3, 4, 5, 6, 7 and 8 particles on each and every corner. Apart from that, because the body center, can we say student, one particle is also present in the center, yes or no, because it's a body center. Okay. What is its contribution? So, if I am talking about the particle in the center student, so for the particle which is present in the center, its contribution is 1. I am hoping you understood why I have written 1. I already discussed in my previous MCQ, yes or no? I am hoping you remember that part. If not, you need to revise that part again. If I am talking about the particle that is present at corner, so corner student, corner particle, contribution is 1 upon 8. We have such 8 particles. So, we are going to write it's multiply by 8, the answer is 1 over here. So, definitely the answer for this question is how many total sphere of constituent particles are present. So, 1 from corner, 1 from center, total is 2 particles. Okay, that is the correct answer. But let me give you one shortcut trick over here, and which says that for SCC, okay, or we can say primitive precisely, BCC and for FCC, okay, the same question, but if they ask about instead of BCC, if they ask about SCC or primitive or FCC, what you will write? You will say it's 1 2 ka 4, okay, 4 2 ka 1, 1 2 ka 4. Remember by this way. So, BCC answer is 2, SCC 1 and so on and so forth. I am hoping you understood this part very well and the shortcut trick. to solve this type of question. Please listen to me very carefully for this type of question, because this type of question, trust me, it is actually very much time consuming. Yes student, if this type of question comes in your exam, be very much careful, because you can say that this type of question you must have solved for your theory exam also in the numerical part, that is 3-marker question. It is there, the same they can ask to consume your time in exam for the MCQ test also. The question says that a metal has a FCC lattice, the age length of the unit cell is 404 picometer. Please pay attention to the unit they have given to us. Age length it is there, so can I say it is the value of A they have given to us. Density of a metal they have given to us. Please pay attention to the unit over here also. The molar mass of the metal is, okay, and the Avogadro number they have given to us, Avogadro number value they have given to us. The formula is very easy student, okay. What is the formula for this? We can say that density is equals to Nm A cube Na. Na, that is nothing but our Avogadro number which is given to us over here, Na, Avogadro number which is given over here. So rho, that is density, small n, what is that? Number of atoms, that is particle present per unit cell. So for that we know that for SCC we have 1, for BCC we have 2, and for FCC we have 4. We have discussed 1, 2 ka 4. Yes or no? So students, over here n ka value that we are going to take is 4. I am hoping you understood this part very well. So we have got our n ka value, density is given to us, molar mass we need to find out, Avogadro number is given to us, A, age length. Please pay attention to this very well, because the unit is picometer, while in density we have centimeter. Okay, so I need to convert this picometer into centimeter. You need to remember 1 picometer is equals to 10 raised to minus 10 centimeter. Remember this part very well. So we have 404 picometer, so centimeter 404 into 10 raised to minus 10 picometer. Yes. Now what? Substitute the value and get the answer. As I said, it's a time consuming question. So let's solve. Let's try to understand. So we have molar mass this. Shuffle the values. So we have density A cube Na upon what? Upon N. Yes or no? We have density ka value which is given to us, it is 2.72. Okay, so we have 2.72 into A cube, but in centimeter. So 404 into 10 raised to minus 10 cube, Avogadro number 6.022 into 10 raised to how much? 10 raised to 23 divided by n ka value. For FCC we will be using it as 4. Yes or no? So we need to take the cube of 404, 2.72. Make sure this 10 raised to minus 10, this is 10 raised to minus 10, but as it is going to cancel out with this 10 raised to 23, the remaining part will be there, that is 10 raised to minus 7. We need to solve this part, and when we solve, we are going to come up with the answer, which is nothing but 27 gram per mole. But obvious log table will be provided to you. If it is there, direct answer you will be able to get from the log table, or you can just approximate the value, few values you can approximate and try to reach the answer. Why? Because if you can see, the options are not very much close to each other. There is some gap in between that. So it's okay if you take approximation and try to get the answer for it. Am I clear with this? So be careful when such type of question comes. Okay, make sure unit conversion is done properly. I am hoping you understood this part very well. Which metal crystallizes in a simple cubic structure? Yes, for that you need to remember the examples of all the cubic unit structure that we have studied till now. Over here they have asked us about the simple cubic structure. Let me give you the direct answer for it. So over here polonium shows simple cubic structure. I want you to remember other examples also. For what I am trying to say is that copper and nickel shows face center cubic structure, and ion shows body center cubic structure. You need to remember. So remember, if the question was for body center, you would have marked iron, face center copper and nickel, and polonium is a simple cubic structure. But always in this MCQ they have asked simple cubic, so polonium is the correct answer. But I have also given you the answers for FC, that is face centered and body centered also. I am hoping you are going to remember this all examples. Read it carefully. A metal crystallizes in face centered cubic structure, that is FCC structure they have asked us, if the age of its unit cell is A, the closest approach between two atoms in a metallic crystal will be. Student, you need to remember, if we are talking about phase centered cubic structure, that is FCC structure, the closest approach between the two atoms in a metallic crystal is nothing but what? Half of the face diagonal. Yes, between the two atoms or particles that we have. Okay, so this is the simple thing that you need to remember for FCC structure. But the thing is very important, the thing which is very important over here, for FCC, the phase diagonal value that we already know, it is nothing but what, student? It is nothing but root 2 times A. A is the age length, so age length ka root 2 times A is the phase diagonal value for FCC structure. Yes, this is the formula for the closest approach between the two atoms in the metallic crystal. Okay, this is the formula. Instead of phase diagonal, we have substituted its value. So our answer should be root 2A by 2. This should be our answer, but if you see in the option, there is no such answer is present. Okay, so there is little bit twist they have given to us over here. So what we are going to do? We are going to do one simple mathematical expression over here. So we have root 2A. Can I write it 2 as root 2 multiplied by root 2? Definitely root 2 is going to cancel out. We will be having with A upon root 2. That's it. This is the value. So this is option number D from this all. I am hoping you understood this MCQ very well. I am hoping you understood level 1 MCQ very well. Let's go to one more level up, that we are going to solve level 2 MCQ. Students, though they are not easy as level 1, okay, you may require little bit more thorough practice, attention, revision for this type of MCQ, but don't worry, with us you will find this type of MCQ also very easy. So we have our first question in front of us, which says that experimentally it was found that metal oxide that we have has formula. This is the important formula that we need to understand for this question. Metal M, we have metal symbolizes M, is present as M plus 2 and M plus 3. So, two oxidation state in which this metal M is present, that is plus 2 and plus 3 in its oxide. But obvious, fraction of the metal which exists as M plus 3 would be what? Okay, but obvious, we want to find the fraction which exists as M plus 3 only. So, let's assume M plus 3 is X. Yes, very easy, the simple mathematical expression that we do. So, M, metal in plus 3 oxidation state, we have considered it as X. So, now the important part is that what for M plus 2 would be what? So, see, in this metal total is 0.98, yes or no, and plus 3 is X time, plus 3 is an X amount, yes or no. So, we can say that simply by this simple logic that total minus M plus 3, the remaining part would be for M plus 2. Simple logic, very simple logic, student. I am repeating myself. We want to find for m plus 3. To make this thing simple, I have assumed it as x. For m plus 2, what? The total minus x, the remaining would be for m plus 2. The next important part over here, we have been provided with metal oxide, yes or no? So in case of oxygen, its oxidation state is -2. So can I say this is a neutral atom that we have? So whatever metal that is present over here, its oxidation state, that is whatever 0.98, its oxidation state must be +2 so that we get neutral atom. Yes or no? I am hoping you understood this simple logic very well. So because oxidation state is +2, for this, to make this atom neutral, we are going to say the total answer that we should get is 2. Now oxidation state is 3 for this m plus 3, so we will be writing it as 3x, okay, be writing it as 3 times x to balance it, just a simple thing. It is present 2 times, so oxidation state is +2, so we write it 2 times into 0.98 minus x. Yes student, I want you to solve this simple equation, and therefore what answer we will get for x? Just solve and tell me the answer. Pause the video, solve the question and tell me the value for x. Approximately value for x that you will be getting is around 0.04. Now comes the important thing. They have asked in percentage. See, in percentage they have asked, not the normal answer. Now, if it is not the very close over here, see both options are very much close to each other, I would have told you direct mark the option and go ahead. But as both options are very much near to each other, we need to solve further as they have asked the percentage value to us. So how we take percentage? The value upon total value into 100, yes or no? So the value for x is for what student? X is for m plus 3 and they have asked for +3 only, yes or no? So we can say that for the percentage, we will definitely do that. Percentage for m plus 3 would be, we have 0.04, total is how much student? 0.98. Percentage they have asked to multiply by 100, necessary it is there. When you solve this, you will come up with the answer as, precisely you need to do, because this both answers very much near to each other. Precisely you need to solve and you will get the answer as, yes, if your answer is 4.08, you are absolutely right, okay. I am hoping you understood this type of question. Student, make sure the question must be there in your mind, that why it is not MO instead of this is 0.98, because over here metal is present in both m plus 2 and plus 3, okay. So there is a metal deficiency defect that happened over here, and because of that we have got this ratio as not 1:1 but 0.98:1. So we need to find out how much m plus 3 was present, and we did that, okay. I am hoping you understood this type of question. You need to be careful, but always require some practice for this type of question. The age length of a face-centered cubic unit cell of an ionic substance is 508 picometer, which is given to us. So can I say the age length, means A value is given to us, which is 508 picometer. No need to change the value, because no need to change the unit, because all the answers which is given to us is in picometer only, yes. If the radius of the cation is this much, so what is the radius of the anion? They have given to us, they have asked us, okay, they have given the value for cation radius but asked us about the anion radius, yes or no. For the FCC structure, student, we know that, okay, let me write that part also. The cation radius they have given to us is 110 picometer. They have asked us about the anion radius. I am writing it as x. Yes, student. So for the FCC structure, student, we know this part, the age length. Okay, age length is how much? What is the relationship between age length and radius? You will tell me that, ma'am, for this we have cation का radius, then anion का radius, it is twice of the age length. Common sense. 2 times radius is equals to age length, 2 particles that makes up to the age length. Yes or no? So, simple thing that we have written. Let's substitute the value and get the answer. So, here we can say the cation value is what? 110, that has been given to us. Anion value we need to find out, and age length they have given to us is 508 picometer. Solve this and get the answer. So, what will be having? X equals to 508 divided by 2, you do it and take this 110 over here, okay, take this 110 over here and solve this. You will get the answer as, what answer you will get? Okay, just divide this and subtract it with 110. The answer that you will be getting is approximately around 144 picometer. So, this is the answer for this type of question. Though this is very easy, but if you do it by yourself in first attempt, you may not get it in the correct way. So, I am hoping after understanding this, if some question like some question related to this asked in your exam, you will be able to solve this. Yes, student. 3 elements that is given to us, X, Y, Z, crystallizes in CCP lattice with X atom at the corner. Remember, so we have X atom at the corner and Y atoms are what? Y atoms at the cube center. Cube center means in the body of the center, in the body center part, okay. So, it is in the center part, Y is in the center, and Z atom at the age center, okay students. So, it is present in the age part, age center part, okay. I am writing just age over here right now, okay. The formula they have asked for this compound. Some simple thing that we need to do is that, as we know, whatever atom is present at the corner, its contribution is 1 upon 8. Yes or no? We have discussed this part in level 1 MCQ. How many such particles are present in one cube? We can say such corners are 8. So, 8 particles in total. So, the answer would be 1. Yes. For the center, but always present inside the center, so no sharing with other unit cell. So, its answer is definitely 1. Yes, student. Okay, its answer is definitely 1. And for the age center student, as we know, it has been shared by 4 unit cell. So, its contribution would be what? Tell me fast. Its contribution is 1 upon 4. We have such 12 ages. Okay, so let's multiply this by 12. So, 12 ages, 12 particles on every age. So, the answer would be 3. So, we have X 1 time, Y 1 time, Z 3 time in the particular cube structure. Okay, so it's X, Y, Z 3. Mark the option and go to the next question. NaCl type of crystal with having coordination number 6:6 can be converted into cesium chloride type crystal with coordination number 8:8 by applying what? In short, if you can understand, we want to convert NaCl into cesium chloride. Means what? Means simply is that the ratio over here, coordination number ratio is 6:6, over here it is 8:8. In short, we want to increase its coordination number. So, how we can increase coordination number of any compound? The simple answer is that by applying pressure. So, make this part very much clear in your mind that by applying pressure, that is by increasing pressure, we can increase the coordination number. By increasing pressure, coordination number, I am writing in short CN, coordination number increases. Okay. So, student, for this question answer, but obvious it is high pressure. But what if in exam they have asked the reverse of it? Reverse of it means what, student? Let me tell you. So, reverse of it means what, student? Suppose in exam they have asked you that you want to convert cesium chloride into NaCl, means what we are doing? We are decreasing the coordination number. Yes or no? From 8 we are decreasing it to 6. So what we are going to say that for decrease in coordination number, for decrease in coordination number, what you will do? You are going to increase the temperature. Increase the temperature. Okay, I am hoping this much part is very much clear. Repeating myself, remember like this way: to increase the coordination number, increase the pressure. To decrease the coordination number, increase the temperature. This is a very important note. Please jot it down. I am hoping you understood this part very well. So in this case, answer is high pressure. By applying the high pressure, we are going to convert NaCl having a coordination number this to cesium chloride coordination number. Yes student, I am hoping you understood this part very well.